Hey guys, it's Mr. Rysz here. I'm going to help you guys out with P4, the pre-calculus fourth section here, finding models of data. Now, this section we will probably spend more time on throughout the year. So if you really struggle with this, if this seems crazy, don't worry, we'll go over this. Pretty much when we do labs, we're going to try to make sure we practice the skill. So what we're going to be doing is looking at models of fit. When we do labs, our data won't be exact, but we can use those models to help predict some things and do some other things with it. So we're first going to make sure we understand what a correlation is. So there are a couple different types of correlations. When you have like a negative correlation, it looks like the data tends to go down. Positive goes up, going from left to right. No correlation means the data is all over the place. And then you can have what's called nonlinear correlation, where the data does follow a pattern, but it's not just a straight line going up or going down. There's a curve to it. So we're going to make a couple sketches of some nonlinear correlations here first to make sure we understand what they look like. And here we go. So let me go ahead and start sketching out. Now they could be anywhere on the graph, but typically most models look in just the first quadrant where the independent and the dependent variables are positive. And I'm going to try to do my best here. Let's see how well this drawing works here. Maybe I'll use like larger markers here. Let's see how well this does. All right, so quadratic correlation is like the one at the beginning where the data just kind of goes up and then goes down. So it follows like a curve here, going up, going down. It could be a U shape as well, but anything that would be like some type of parabola. A cubic, well, that's a graph that goes up, goes down, and then back up. So there are two changes in the graph. It could go the other way, down, up, and then back down. So there we go. Exponential graph, this would be something that we've been dealing with at the beginning where it starts off low, and then all of a sudden it changes and starts getting higher. So you can talk about like daily corona numbers, exponential growth. And logarithmic is the opposite. It starts off really high, and then gets lower and lower, and then flattens out to a curve. So this could be like the amount of carbon, you know, I don't know science too well, but like the amount of carbon molecules in an atom over its life, you know, it typically goes down, cuts in half the half-life of that. Okay. So next what we're going to do is using those data and finding lines of fit in the calculator. So this is a lot of notes here. I'm going to walk through this whole thing for you. But this is just an example walking you how to get a linear regression on a calculator. So if you want to read through that, you can, and you can always go back to this if you get lost. But I'm going to, in this video, walk you through this. So we have this data here that we're going to try to get our representation for, which we probably can get a good sketch of the graph here too. So what I'm going to do now is to plot these points here on a graph as best as I can. Just get a sketch of this graph. All right, so we get 1890, and then we got like 1900. All right, then 10, 20, 30, 40, 50, 60, 70, 80, 90, and then 2000. Now, okay, ages, we'll put a little break here. What's the lowest we get down to? Like 20? And then what's the highest we get up to? 25, 26? Okay. So let's see, 20, 21, 22, 23, 24. Okay, there's 25. All right, so if we're going to plot those, okay, 1890, we're at like 22. 1900 just below that. 21.6. 21.2. 21.3. So we're still just above the 21 mark. 21.5, 20.3. Oh, what happened there in the 50s, 60s? 20.3. Baby boomers. Okay, boomer. Is that the thing kids do nowadays? 18. Okay, then we go up to 22. 1990, we get the strong, independent American working mother. All right, then 21 and a half. Okay. So we have a graph that kind of goes like this. All right, what type of correlation does this graph represent? Now, I would probably say that this represents like a quadratic. We could argue that it's cubic because it kind of a little up, little down, but I'd say quadratic. Typically it's going down, then up. There is kind of this other curve here, but I would say quadratic. And let's find the equation of best fit. Now, in order to do that, I'm going to clear this off. Remember, you can always pause and go back to the video. Need help? I'm going to use the graphing calculator. In fact, we're going to use everything else on the graphing calculator. So I'm going to put this stuff into the graphing calculator. If you've never used data sets before on a graphing calculator, well, today I'm going to show you. In order to get to this, we're going to press the stat button and we're going to go to edit. What this gives us is a list that will be stored of information into the calculator, and list 1 is our independent, and we're going to type in, hopefully I can type, yeah, thank God. We're going to type in the X values, so our dates, so 1890, 1900, 1910, 1920. Okay, so if you want to skip ahead, feel free to do that. I'm going to type these all in, and I'm also going to fight back a sneeze at the same time. No, I'm not. I'm losing. 1 second, bud. I'm making a video. '93. Oh, that was not 1993. Ooh, and I've noticed another mistake. Simple mistakes like this, guys, will make a big difference in your answer. So double take your time. Make sure they're right. 1993. So hopefully you guys have a graphing calculator. If not, you have that extension on your Chrome book. All right, and now list 2, I'm going to put the values here. So we got 22, 21.9, 21.6, 21.2, 21.3, 21.5, 20.3, 20.8. Ooh, am I off here? Yeah, I am off. What did I mess up? 18, 22, 19.9, 1920. Oh, there was 2 of them, 20.3, another, okay, 20.8, 1970, 22, 23.9. Yeah, it's very important that you guys take your time here and double check that every data matches up in the right. Otherwise, you'll do all the other right steps. Dang it, like I messed up another one here. All right, 1990 is 20, and then 24.5, 24, oh, another 24.5, 24.8, 25, 25. I was talking too much. Okay, so we got that all in our information. Now, if we want to see that on a graph, we got to do a couple things. One thing we're going to do is press our Y equals. I'm going to clear off this. But what we're going to do is turn plot 1 on. Plot 1's default is to get the coordinates from your list 1 and list 2 and make them as a point. But if I click graph to see it, it's not going to be on there, because the other thing is our window isn't set. These are values, like this is the point 1890, 22. So we got to change our window. So if you press second window, actually no, not second one, just straight up window, we got to change our scale here. So our X min, so what's the lowest number? We got 1890. I'm going to go a little bit lower than that. Our X max, well, we go up to just about 2000. So I'm going to put 2000 here. Don't worry about the scale. That's just how many tick marks we'd want on each one. I mean, we can put 10 here. It means like we'd see a spot every 10 years. All right, little dash. All right, now Y min, what's the lowest we get to? The lowest is we get is 20, but we'll put 18 here for all legal age purposes, although I think that age changed in there in 1800. And the highest we get up to is 25, so I'll put like 27 up here. All right, now if we graph, our window will change and we can see our points of what we graph. Another way we could have done this here, if you press zoom, and this is not on all calculators, but some of them, you press zoom stat, it will find that information. It will look it up and automatically calculate it for you. So, okay. Next, how do we get a line of best fit? So this is the second part. What we're going to do now is press stat, but we're going to go over to the calculation tab. And here we have different ways of doing this. There's a linear regression. So if we think the graph is a straight line, we can get that. A quadratic regression, or a cubic, or quadratic, or log, or exponential. So I'm just going to show you linear because that's the easiest one to first look out. And there's actually 2 different versions of linear, but we're going to go with the straight mx plus b. If I press enter here, it asks me to set, okay, is my X from list 1, list 2, just leave that alone. The only thing we'd want to do extra is right here, store regression equation. This is a nice little step that's going to make everything look nice. In this store, if we press the vars, go to Y vars, click function, Y1. You know what? I'm not sure if you guys are seeing this. I've just realized this. I hope you guys saw all this. So function, oh man, I might have to re-record this. Oh well, Y1. Then click calculate. What this does is here we get the equation where, okay, here's our M, our A number, here's our B. But the one thing that we did, that store, if we click graph, it will draw that line in. So, okay, a linear regression, not that great. So if we want to do something better, okay, all we got to do is press stat, do calc. Instead of picking linear, let's pick quadratic. Pick quad. The same thing, we'll skip, just do store, regular regression, the regression equation, press vars, Y vars, press enter, enter for Y1, and go down, click enter on calculate. So here we get a quadratic equation. Let's see how well that looks. Looks okay, not the best, but okay, let's check like cubic. Maybe that might be better. So stat, calc, cubic, we'll store that, vars over Y vars, enter, enter for Y1, calculate. Okay, let's see that graph. Okay, I would definitely say that is a much better, so this is not a quadratic. I would definitely say that's a cubic equation. So if we go to Y equals, there's our equation. I think if we quit out, we can, oh no, we can't, not on this calculator. So once again, if I want to answer these problems over here, all right, what's the equation of the graph? And then do the interpolation. All right, let's try to answer these. So I'm going to get that equation by just doing the cubic regression again. I could store it, but I'm just going to calculate it here. It should automatically be stored here. And let's answer these questions. So here we go. Let's draw them here. All right, what's the equation of this? Now this is a little tricky here. This is scientific notation. So I'm going to have to move the decimal point over 5 spots. But that would be, if I move that over 5 spots, 0.00018 x cubed. So that's the number for A. Now B is, oh, not plus, but minus, because it's negative. Minus 0.10598. Okay, don't have to get this specific because we're going to use the calculator. Okay, and then the next number, x squared, and then we got plus 204 x, that's good enough, and then minus 130888. Okay, so we're just getting an equation right here. What we can use that equation then is to figure out, so if we had to use this equation to find the median age, the average age of the first marriage of a woman in 1955, I mean, looking at this, we'd probably say like 20.3. But the one thing that's kind of nice here, if we use the calculator, okay, we have that on a graph here. If I go to the table, or even if I think if we do this trace, if I just type in 19, oh no, it doesn't work on this one. Okay, so we got to go to our table. We might have to check something with their table. Okay, so if your table looks like mine, which I'm hoping you guys are seeing it, we're going to have to change this up because I could scroll all the way down to 1955, but, or can I type it in here? No, it won't let me. So we're going to press second window, change your table settings. And I think this would be a good thing for you to always do. Make your independent variable on ask. What that will do to your table now, it leaves it blank, but it allows you to type in your X numbers. So I could type in 1, I could type in 2, and it'll tell me the answer. But I mean, right here, I'm going to type in 1955. It's going to plug that number into the formula and do the math for me. And we would get an answer of 20.5. Yeah, we can just say 20.5. All right, what's the median age in 2016? So you can see here, we can go ahead once again, and just instead of scrolling through, we just type it in 2016, 31.18, which isn't too bad. Now I think this is where the it gets wrong, because I mean 4 years later, let's see how crazy in 2020 would be. 32 point, okay, so not too bad, but here we go. Okay, so we'll use this calculator to help us out a lot as we move through. Okay, let's move on to the next one. All right, hold on guys, I gotta pause this video to get my son some fruit snacks. Okay, this next one I put on here on purpose, not because it's such a difficult problem, because a lot of kids will see in math just a whole lot of words and a whole lot of graphs and numbers and just get scared. I just want to show you how easy some of these things are. So we got Mr. Hong's class did an experiment by rolling a marble down different lengths of slanted boards and timing how long it took. The results are shown below. So they plotted the points. I have all those right there. Plotting the data shows the scatter plot at the top right. The data appears to be the shape of a parabola or quadratic. Sketching the curve approximates the data shown below by guessing and checking using Algebra 2 skills, or by entering the data into a graphing calculator, which is like what we did. They figured out the equation is y equals 0.5x squared is good. So they tell us the equation of the fit right there. So based on the equation, approximately how long will it take the marble to roll 15? Well, if we want to figure that out, all we would need to do is to take the approximation model here and plug in 15. So what's 0.5 of 15 squared? Well, that would be what? 225 over 2. Okay. Oh, wait. Am I working it backwards? No. Alrighty, and then here we go. Approximately how far will the marble travel in 3 seconds? So what we would have to do is work backwards there. So 3 equals 0.05 times, or did I work these backwards? It would make sense that you're into X's and Y's. Oh no, wait, no, X's is second, Y's is centimeters. Oh, I did do these backwards. Hold on. Sorry. I got these mixed up. I was wondering why the number didn't work out. So our X is seconds, our Y's is centimeters. Maybe I need to write that. So centimeters and seconds. Okay, so if we wanted to roll, how long would it take to roll 15 centimeters? We're gonna set 15 equal to the Y, solve for the X. That's why it's kind of difficult to use just X's and Y's all the time. Okay, multiply, we get 30 equals X squared. Take the square root of that. What's the square root of 30? I don't know, probably about 5.5. Then if we want to do the other way, approximately how far will it travel in 3 seconds? So Y equals, we're finding the centimeters, 0.5 times 3 squared. So that would be about 9 over 2, or 4.5 centimeters. So just to show you guys too, a lot of times if I give you a big word problem, just take a second and read it. It's usually not too bad. As long as you know. Okay, so you got your homework here today. In the CYU, just take your time using the scatter plots. It really isn't going to be too bad. Some of them you can see are pretty easy. I've basically taken these problems here and simplify them down. So if you guys have any questions, make sure you guys ask, email me, or when you see me in class, or even on the video chats on Monday. If not, have a great day, have some fun. See you next time.